Hi guys, welcome back. So today we are going to continue or maybe start simplifying expressions involving rational exponents. So first a little friendly reminder from round one. So how do we write a expression that has a radical in exponential form? So pretty much this. So I'm just going to copy it, but I'm going to speak to you. So if we have nth root of b to the m, how can I write it in exponential form, or how can I get it out of the radical? So you're going to keep the base and write the exponent as a fraction. So to do that, it's current exponent divided by the index. So you can remember with the variables, but for me it's really hard to remember nth root of b to the m equals b to the m over n. Who has time for that? Not I. I remember it with words. Now, what if you had something like this? Okay, so something with a rational exponent, so a fraction exponent. So remember, whenever you have a rational exponent, that is code for hidden radical. Okay, so if we have b raised to the m over n, I'm like, oh look, we have a rational exponent, which is code for hidden radical. So to write this in radical form, we're going to start with the denominator. Since the denominator is n, then that will give us the nth root of something. Nth root of what? Nth root of whatever we're left with. And in this case, it's nth root of b to the m. And that's it. Okay. Now, what if we wanted to tone this down? If you want, you can take the exponent outside of radical. If you're an overachiever, we can write this as nth root of b, and then we'll raise the entire radical to the nth power. So do what you gotta do. So friendly reminder, remember for this course, a non-graphing scientific calculator is required. So here's my non-graphing calculator. We're going to use a couple of buttons, well, a handful of buttons, but the one I want to point out is the logarithm button, so the one that has log. So if your calculator has that button, then it's pretty much going to have all the other buttons that we will be using. So just a friendly reminder. Okay, so without further ado, we're going to do a total of 8 problems spread about 2 separate fun problems. So for fun problem number 1, we got 2 problems, and for fun problem number 2, we got 6, and then we're out. So let's do this. So fun problem number 1 reads, evaluate each exponential expression. Okay, fantastic. So exponential expression, because it's an expression that has an exponent. So by some miracle, I'm supposed to evaluate 625 raised to the 1/4 power. I have no idea what that means. I can't even grasp the concept, but we're going to do what we got to do. So I know that you know that whenever you have a rational exponent, that is code for hidden radical. So let's do this. Since the denominator is 4, then that means that the index is 4. So that will leave us with 4th root of whatever we're left with. And in this case, it's going to be 4th root of 625 raised to the 1st power. I know that you know that we don't need the exponent of 1, but the reason why I wrote it for the notes is because I wanted to highlight that we don't just ignore the numerator for fun. Okay, so 4th root of 625, by some miracle I'm supposed to know that, but we don't have time for that. So let's go ahead, prime factor the 625, and then take it from there. Okay, so with your calculator, let's go ahead and do this because we're not gonna freehand it. So I know that 5 is a factor. When we punch it in, it'll be 5 times 125. We break down 125. 5 is also a factor. We punch it in, and that will give us 5 times 25. And then we don't need a calculator no more. Branch out the 25, and that will give us 5 times 5. Now someone said, do we need to show the factor tree? You don't. Okay, just write 625 as a product of prime factors. Okay, so 625 as a product of prime factors, that will give us 5 to some power. 1, 2, 3, 4. Okay, so 625 as a product of prime factors will give us 5 to the 4th power, and then we'll bring down the rest of the problem. And then at this point, I'm jumping for joy because I'm like, oh look, index is 4, power is 4. Since they're the same, thanks to our earlier video, we know that they undo each other, and that will leave us with the radicand of 5. So that's it. Cool. So 1 problem down, 1 more to go for this round. Next problem, we have negative 32 raised to the 1/5 power. Who knows the answer? Not I. Okay, so let's go ahead, do it however we can. Whenever we have a rational exponent, that is code for hidden radical. So let's do this. So since the denominator is 5, that means that we're going to have that the index is 5. So that will give us fifth root of whatever we're left with. So I cover it up, and that will be fifth root of negative 32 raised to the first power. Negative 32 raised to the first power. But again, when the exponent is 1, we don't really need it. Okay, so if you feel comfortable to answer right away, go for it. But I really don't. So what I'm gonna do, I'm gonna write 32 as a product of prime factors. To facilitate the process, we're gonna use a factor tree. So you branch it out however you want. One way to go about it is 8 times 4. We branch out 4, that will give us 2 times 2. We branch out 8, that will give us 2 times 4. We branch out 4 encore presentation, and that will give us 2. 2 times 2. So the moral of the story is that 32 is the same as 2 times 2 times 2. That's 3, 4, 5 as 2 to the 5th power. Okay, but bear in mind that we want the negative 32. So be negative 2 raised to the 5th power. So we're still taking the 5th root of negative 32. Now the question is, how are we going to handle it? We'll check how are we going to handle it. Hopefully I said that correctly. Okay. Index is 5, power is 5. Since they're the same, they undo each other, and that will leave us with the radicand of negative 2. I'm getting tongue-tied today. I need to rest. Okay, cool. Alright, so that's fun problem number 1. I'm going to take a pause and write the directions for fun problem 2. Alright, so let's do this. So fun problem number 2, the directions read write each exponential as a radical. Okay, we got this. So we have 3 raised to the 1/2, and we are asked to write this exponential expression as a radical. So put it in radical form. So remember, whenever we have a rational exponent or fraction exponent, that is code for hidden radical. We're going to pay special attention to the denominator. Since the denominator is 2, then that means that the index is 2. So we have square root of whatever we're left with. We cover up that denominator. That leaves us with 3 to the first power. So that will give us square root of 3 to the first power. So that is the answer. Okay, we are asked to write it as a radical, and we did. But we need to write this as clean cut as possible. When the index is 2, we never write it. So we're not gonna start writing it now. When the exponent is 1, we never highlight it. So that's it. Okay, so we want to tell the world 3 to the 1/2 is just fancy talk for square root of 3. So let's do this. So we're doing a total of 6 problems for this round. That's our first one. Let's go ahead and knock out the second one. Problem B, where am I? We have 3w raised to the 3/4, and we are going to add to it 4x raised to the 1/3. So remember, go ahead, pause and rewind as many times as needed. Okay, so I'm going to try to zoom in as much as I can. Okay, I think that's as big as I can go. So the directions, write each exponential as a radical. So write each exponential expression as a radical. So again, rational exponent, that is code for hidden radical. So let's do this. So the denominator is 4. The denominator in the exponent is 4. Since the denominator is 4, then we're going to tell the world that the index should be 4. So that will give us 4th root of whatever we're left with. 4th root of 3w raised to the 3rd power. 4th root of 3w raised to the 3rd power. And then we're going to add to it whatever this is in radical form. We have a rational exponent, which doesn't quite look like a fraction because I wrote it too low, but I can't fix it. Okay, so this is supposed to read 4x raised to the 1/3. Okay, since the denominator is 3, then that is code for index is 3. So that will leave us with cube root of whatever we're left with. Cube root of 4x raised to the 1st power. I'm not going to bring down the 1 to remind myself because I already did it a few times. Cool. So if you give me this, I'm good. Now, if you want to do what your book does, the book says this. Wouldn't it be nice if we clean the radical so it doesn't have any exponents inside? Whatever, I don't really care. So let me just go ahead and write book. and we're going to take this exponent outside. So we're going to write this as, I have to zoom out. We're going to write this as 4th root of just the base. And then instead of just raising the base to the 3rd power, when we take the exponent outside the radical, we're going to raise the entire radical to the 3rd power. So we may not see the benefit right now, but hopefully if I did this right in a later video, you will see the benefits of taking that power out. But for now, it's really up to you. Okay, so that's our second problem. Let's go ahead and knock out our third problem. Problem C. We have an addition problem. We have 5x squared plus 3y cubed raised to the negative 5/6. Okay, I'm already exhausted just from writing it, so I gotta remind myself of the directions. So it says the directions, write each exponential as a radical. Okay, so the exponent is a fraction, which is code for hidden radical. Before we go straight to radical form, we gotta fix it so the exponent is positive. Okay, so to do that, we're gonna use the negative exponent rule. How are we gonna make the exponent positive? To make the exponent positive, you're gonna move the entire base to the other side of the fraction bar. If there's no fraction bar, then make it up. So fraction bar over 1, and then with confidence, it's like, okay, I know how to make the exponent positive. Again, to make the exponent positive, we're going to move the entire base to the other side of the fraction bar. So that will leave us with 5x squared plus 3y, well, plus 3 times y to the 3rd. Now that is raised to a positive exponent, namely 5/6, and that's all under 1. Cool. Exponents are positive, so we are on track to getting full credit. Remember, whenever you have a rational exponent, that is code for hidden radical. Let me go ahead and bring down the numerator. Let's go ahead and put this in radical form. Since the denominator is 6, then that means that the index is 6. So that will give us 6th root of whatever we're left with. So I'm going to cover it up, and that will leave us 6th root of this addition problem raised to the 5th power. So let's do this. Addition problem raised to the 5th power. If you give me this, I'm going to give you full credit. Well, let's extend the fraction bar, okay? Because you wrote the exponential expression and in radical form. But again, the book always wants to take the exponents outside the radical, and in a later problem you will see the advantage of doing so. For now, it's more like if you want. Okay, so that will give us 6th root of 5x squared plus 3y cubed, and then we'll raise the entire radical, not the entire fraction. We'll raise the entire radical to the power of 5. Okay guys, so that's our third problem. We're doing a total of 6. Let's go ahead and do our final 3 and we're out. Okay, so problem D has been located. So the directions, a quick reminder. So it says write each exponential as a radical. So we have an expression with an exponent, and we are asked to write it as a radical. Okay, so in this case, let's do this. Remember, whenever you have a rational exponent, that is code for hidden radical. So we're going to highlight the denominator. Because the denominator is 3, and that means that the index is going to be 3. So we have cube root of whatever we're left with. Cube root of negative 8 raised to the 4th power. Cube root of negative 8 raised to the 4th power. So by some miracle, this is how you're supposed to do it. We're supposed to take negative 8, raise it to the 4th power, and then that's where the miracle kicks in. We're going to take that big number and take the cube root of it. But in this case, I'm going to do what the book likes. I'm going to do what the book likes to do, which is take the exponent out of the radical. Okay, so when we do, that will give us cube root of negative 8, and instead of raising the negative 8 to the 4th power, we're going to raise the entire radical to the 4th power. So it doesn't matter where the 4 stands, you're going to get the same answer. The advantage of taking that exponent outside the radical is that it will tone down the radicand itself. Before, the radicand was negative 8 to the fourth power. Now the radicand is just negative 8. I could work with negative 8. So now the question is, what is the cube root of negative 8? So when we keep our cool, negative 8 is the same as negative 2 raised to the third power. Let me bring down the rest of the problem. So that will give us cube root of negative 8, or undercover negative 8. And that is being raised to the fourth power. So let's clean this up. Index is 3, power is 3. The numbers are the same, so they undo each other. And that will leave us with the radicand of negative 2. Cool. We're going to bring down the rest of the problem. What's going on with the negative 2? We're going to wrap it up and raise it to the fourth power. So let's wrap it up and raise it to the fourth power, and negative 2 to the fourth power. When you keep your cool, that will give you, I think, 16. Okay, guys, so I promised you 6 problems. That's our fourth problem. Let's go ahead and knock out our fifth problem. Problem E, we have a fraction. We have 729 over 64. What are we going to do to that fraction? We're going to raise it to the 5/6 power. Okay, fantastic. So gentle reminder, we are asked to take all these exponential expressions and write them in radical form. So rational exponent, that is code for hidden radical. So let's do this. Since the denominator and the exponent, since the denominator is 6, then we're going to tell the reader that the index should be 6. So that will give us 6 root of whatever we're left with. 6 root of this fraction raised to the fifth power. So 6 root of the fraction raised to the fifth power. So again, we have two options to simplify this. Option 1, take the fifth power of this fraction, and then by some miracle take the sixth power of it. Or option 2, let's just get that exponent outside the radical. Okay, so that will give us 6 root of the fraction, and then we're going to take that radical and raise it to the fifth power. Fantastic. Okay, so what are we going to do? By some miracle, you're supposed to take the 6th root of that fraction. I have no idea what that is off the top of my head. So I'm going to go ahead and prime factor it. So we have 729. 2 is not a factor. Who has a calculator? I think 3 is a factor. Okay, it is. Okay, so that will be 3 and 243, or 243 like the cool kids say. Then let's keep branching it out. 3 is also a factor. It will be 3 and 81. And now I'm in my zone. 81, when we prime factor it, that will give us 9 and 9. We branch out the 9s, and that will give us 3 times 3. Same thing with the other 9. Okay, so we're going to tell the world that 729 is the same as 3 to some power. 1, 2, 3, 4, 5, 6. Okay, we have 729 is the same as 3 to the 6th power. Over 64, let's go ahead prime factor it. So 64, the first thing that comes to mind is 8 times 8. We begin to prime factor it. That's 4 times 2. We branch it out. 4 is the same as 2 times 2. And we're going to have an encore presentation on the right side, meaning I'm just copying my work. Okay, so when we keep our cool, we have that 64 is the product of a bunch of 2's. How many 2's? 1, 2, 3, 4, 5, 6. Okay, and that is being raised to the fifth power. So check it out. We have that 729 over 64 is the same as 3 to the 6 over 2 to the 6. Since both 3 and 2 are being raised to the 6th power, to facilitate this process, then we're just going to say, we're going to rewrite this as quotient of 3 and 2 raised to the 6th power, or 6th power of 3/2. So it's up to you. Okay, let's bring down the rest of the problem. That is being raised to the 5th power. So at this point, how are we going to handle it? So check it out. Index is 6, power is 6. From back in the day, if they're the same, pretty much they undo each other. And that will leave you with the radicand. Okay, that will leave you with the radicand of 3/2. We bring down the rest of the problem. This is being wrapped up and raised to the 5th power. we take our time and then we just evaluate it. 3 to the 5th power. Who has a calculator? It's 243. 2 to the 5th power, that will give us 32. We couldn't reduce this fraction, so when we raise it to some power, we shouldn't be able to reduce it either. Okay, that's problem number 5. Let's go ahead and do problem number 6, and then we're out. So F. So that will give us 125 raised to the 7/3 over 125 raised to the 5/3. Yeah, you can't see that, sorry. Okay, so we are asked to write each exponential as a radical. Okay, so those words are just out of my comfort zone. For me, I'm like, oh, fraction, simplify. Okay, so then I'm like, can I simplify it or reduce it? In this case, we're dividing two things that have the same base, so we're going to use that quotient rule for exponents. Okay, so I'm like, oh man, how does that work? I'm like, silly exponent rules, they make me so mad. And then I'm going to circle my feelings. You know how they ask you, how are you feeling today? Because we have a division problem, what are we going to do with the exponents? We're going to keep the base and subtract the exponents. I can care less which of the two exponents you subtract, but if you want to avoid having a negative exponent, then I encourage you to subtract the smaller exponent. In this case, it's 5/3. Okay, so we're going to divide top and bottom by 125 raised to the 5/3. So to do that, this bad boy goes into itself once, and then let me just put subtract exponent. And to see how many times it goes into the other one, we're just going to subtract the exponents. Okay, difference of 7/3 and 5/3 is 2/3, I believe. So that will leave us with 125 raised to the 2/3. Fantastic. We got this bad boy on top divided by 1. We don't need the 1. Okay, so that gives us just 125 raised to the 2/3. Cool, that's the answer. Bear in mind that we are asked to write this in radical form. Okay, so let's go ahead and write it in radical form. Whenever we have a rational exponent, that is code for a hidden radical. Since the denominator is 3, then we're going to tell the world that the index should be 3. So that should give us cube root of whatever we're left with. Cube root of 125 raised to the 2nd power. So again, you have two ways to go about it. You can square the 125 and then take the cube root, or option 2, take that exponent out of the radical. So that will give us cube root of 125. And instead of just squaring the 125, we're going to square the entire radical. So let's do this. Cube root of 125. So you can either go straight to answer or you can show yourself some work. I'm going to go ahead and pretend that I prime factored this on the side. 125 is the same as 5 to the 3rd power. But we want its cube root. And after we do that, we want to square it. So then I'm like, okay, let's go ahead and do what we got to do. Cube root of 5 to the 3rd power. Index is 3. Power is 3. The numbers are the same, so they undo each other. So that will leave us just with 5. What's going on with the 5? We're wrapping it up. And then we got to square it. Last time I checked, the square of 5 is 25. So the moral of this story is that the quotient of those two bad boys, I can't even project it. Okay, the quotient of these two bad boys, after all this work, after all that heavy lifting, just gives us 25. Okay guys, so I said we were going to do 6 problems. That is our 6th and final problem. So I'm out. I mean, you're out. Thanks.